filter placement. It's the same as ground routing. We get the connector on the bottom left side. The switching voltage regulator is on top, and the filter is showing to the right side. Do you think that current wants to take the long path to pass by your filter, that your filter can act? One of the main components of a filter, as you can see, and this is just a very small one, are capacitors. Capacitors only can act if they see a voltage difference. But the currents from switching voltage regulator and everything else, these are high-frequency currents. They don't take the long path. They try to keep the space narrow. So if the current does not pass by your capacitors, your filter is useless. And I had many PCBs with filter structures, all type of components you get from Wirth Electronic, at least 6 to 8 components. We removed them all, same spectrum. Obviously, filter is useless. You can save a lot of money. Of course, you don't get any more jelly bears, but you can save the money for the components. I don't want to encourage you to save the components. You will need them. What I want to say is apply the filter correctly. So if you enter the connector, your first ground connection is not at the connector. Your first ground connection to your PCB main ground is at the end of your filter structure. So your current is enforced to pass by your components. All the voltage-dependent components see the voltage difference. They can act as a voltage-dependent device, and they can be a filter. And if you make filters like this, always it's a pi structure. You always get some capacitors shunting to ground. You get some resistance as inductors and ferrite beads. And 80% of the filters I see, it's these 1 to 2 microfarad caps, maybe 10 microfarads. You have a ferrite bead, and again 10 microfarads. Filter is useless. If you look at the impedance curve of a capacitor, there's a very significant dip. And for a 100 nanofarad, it's at 10 megahertz. For a 10 microfarad, it's far below. It's around 1 megahertz. If you take the ferrite bead and you check the impedance curve of the ferrite bead, the top is at 100 megahertz, 150, 200, depending on the type of ferrite bead you're using. So you have lowest impedance at 1 megahertz for the capacitor and highest impedance at 100 megahertz for the ferrite bead. How do you want to build a filter? So choose an inductor which acts at 10 megahertz or 1 megahertz, depending on the problem zone you have with your board. If your problems are at radio frequency, you have to use ferrite beads, but then use capacitors that have the lowest impedance at 100 megahertz. Go for 1 nano, 100 pico, depending on your supplier. And this is why all the suppliers deliver you these data sheets. They don't do it because they have to do it. They want to give you the opportunity to choose the correct component. 80% of the filter I find in automotive applications are wrong. And people always wonder why they don't work.